Welcome to Ask and Learn.
Okay, so we want to find the largest n for which one can solve within 1 second a algorithm which requires f to the n operations with each. So basically what this says is how many operations can be performed given that each bit operation is carried out in 10 to the minus 9 seconds. So first, what we want to figure out is how many bit operations can be performed first. So we have one operation can be performed in 10 to the minus 9 seconds. So what we want to go instead is we want to go from 1 second. So if we're going from 10 to the minus 9 to 1 second, we multiply each side by 10 to the 9, sorry. So 10 to the 9 operations. So then to find the largest n for a, we have log n. So yeah, log n. And we want to solve log n is equal to 10 to the 9, or really log base 2. So to solve this, you just have to use your log laws. So n is just 2 to the 10 to the 9. So where I got this from is if you have log base a, b is equal to c, you just have a, c is equal to b. So b will be your n, a will be your 2, c will be 10 to the 9, and you have this. So for d, you have n, and this is equal to 10 to the 9, and that's really just it. Well, this is b. And for c, we have n log n is equal to 10 to the 9. Now, this you can try to solve this. It's very difficult to solve this. All I can tell you is that there's just a function that does this for you, and it gives you n is equal to 3.96 times by 10 to the 7. And to get this number, you need to use the Lambert W function. And this is just a very complicated question. I barely even know how to solve this equation, but that's what the answer is. Now the 2 to the n, n squared is equal to 10 to the 9. So just take square root of both sides. N is equal to 10 or 9 square root of 9, which is just 10 to the 4.5. And you can write this as 31622, so 31,622. E 2 to the n is equal to 10 to the 9. You just take log base 2 of both sides. You have n is equal to log base 2 of 10 to the 9. This is 9 log base 2 10, which is just equal to 29. So this is just log laws. Log laws. F, you have n factorial is equal to 10 to the 9. And to do this, what we have to do, if you get a list of factorials, you know that 12 factorial is equal to 4.79 times by 10 to the 8. And you know that 13 factorial is equal to 6.23 times by 10 to the 9. So what we know then is that n must be between 12 factorial and 13 factorial, because 12 factorial is less than 10 to the 9 is less than 13 factorial. So what this means is that this n must be somewhere between 12 is less than n is less than 13. But since we're working with factorials, and at least for this level of mathematics, saying 12 is good enough.